Okay, I think we are ready to go. Welcome, everybody. My name's Dawn, and I'm going to be hosting today's Tech Talk on collaborative workflows. We're really excited to have you all here today. And if you should have any questions or just want to say hello, you can drop that in the chat or the QA feature. We will be monitoring both throughout the day, and then we'll be doing some dedicated QA time at the end. So with that, I'm going to turn things over to Ryan, our presenter today.
Thank you, Dawn. Hi, everyone. I'm Ryan, co-founder and CTO at Nextmove, and this over here is my cat. I'm going to be talking to you today about collaboration in optimization or decision science, depending on what you call it. This is a topic I'm really excited about for a couple of reasons. One is that we've just been focusing a lot on that in our product development here at Nextmove, but also if you've been around software development for a little while like me, you've seen collaborative workflows really change how we build software and more recently change how data science is done in the workplace. And so it's really cool to start to see these tools come to the optimization space. So I'll give a quick orientation talking about why this is important for collaboration in optimization. And then we'll go through a speed run showing some of the tooling that we've built out and what that means for optimization in practice. We'll discuss the three sort of pillars of collaboration, which are deployment, sharing, and experimentation, and then we'll take time for questions. So let's go into the setup of this. I like to use data science as a sort of a frame of reference because it went through a transformation very recently that is similar to what is happening in the optimization space now. So both data science and optimization have been around since the 40s, 50s or so. And initially they were very much, single person tasks. You had somebody who was working on a bunch of math, usually behind a terminal, maybe using R, maybe using an old programming language or something. And so they were the sort of the focal point of the activity. But what's really happened in the last X number of years is that practice has become a team sport as it's been adopted by more and more technology companies. And key to that team sport is collaborative tooling and workflows that allow the data scientists to function in organizations that comprise data engineers, data stewards, people who understand analytics, the business, DevOps, and engineering. And so this collaborative piece is really what's enabled us to take models that might be sitting on, a machine under my desk, and I'm the only person that can run them, and turn those into well-maintained pieces of software that grow and evolve and adapt to changes in the business. And so these are the things that are sort of essential to, have been essential to adoption and the explosion of data science. And we really believe that the same thing is key to the explosion of optimization that is occurring now. So as we talk about this, we'll go through some of the Nextmove platform because we've been building out tools that enable this collaborative workflow. There are a few different components to that platform. We have a command line tooling interface. We have SDK, a software development kit for building models and solving problems. We also have a console, which is sort of a visual interface around all of this tooling. And then we have a cloud environment in which you can deploy models to. All of these things target sort of different people that have to interact with these models in a production environment. But today we'll be focusing on the console and the deployment side, because these are the pieces that are more of the collaborative vehicle. All right, so let's start with our speed run. We're going to just dive right in and take a look. And in order to do that, let's imagine that instead of my role as CTO of Nextmove, I'm going to switch temporarily over to my role as a decision scientist at the FarmShare company, which is a little-known subsidiary of Nextmove. The FarmShare company grows carrots, and we deliver them to carrot enthusiasts. To do this, we have a fleet of vans that pick up boxes from local farmers and deliver them to our customer homes. We have a routing app that does route optimization for our drivers. Our drivers are actually W-2 employees, which is pretty cool. And they sign up for shifts in advance. And so for us, we have to route them so that they don't go past that shift. Otherwise, we're on the hook for overtime. So we need to be efficient. And of course, the vans that they drive have limited capacity, pickups have to proceed drop-offs, and sort of all the other constraints and operational aspects that you would expect in growing carrots and delivering them to end customers. All right, so in that capacity, let's open up our routing app in Nextmove Cloud. So this is our routing app in Nextmove Cloud.
Hey,
and as
Ryan,
you can,
sorry to interrupt. Do you have a minute?
yeah, your timing is interesting. But yeah, what's up, Ashley?
It's just that ops noticed some odd behavior with the routes from this week. The drivers have been working overtime to make all of their deliveries. I'm headed to the airport this afternoon and I need to get the plans out to the drivers before I leave. I don't know why this is happening. Can you help?
Yeah, that's not good. Okay, let's take a look. While I'm pulling up the routes from the latest production run, what feedback have you been getting from the field?
Yeah, so the drivers have been saying their stops are too packed together and they regularly feel like they're behind their schedules.
Interesting. Okay, so this is the route output from our latest production run. I think this was a couple days ago. Visually, it looks fine. There are fewer drivers assigned than normal. Let's look at the output real quick. Okay. Okay, so here's Mariah's route. I mean, the pickups are before the drop-offs and everything. I mean, it generally looks like I expect. Got 4 vehicles and all the stops are assigned. So again, there is something fishy. Values around 47,000. All right, yeah. You know what? Let's pull the input into my editor and just take a look at that.
Okay.
Hey Ash, hey Ryan.
Hey.
Sorry for interrupting. I couldn't help but notice your screen, Ryan, and realize you're investigating this overtime issue.
Yes.
So product is getting copied on emails with finance about the extra cost here. Do we know something?
Yeah, so we were just looking at the output and didn't see anything visually wrong. So we're investigating the input to see if something is wrong there. So this is the input from the latest production run. So far, start and end locations look good. Shifts look right. Speeds and capacities are right. Oh, here's something. So it looks like the stop duration field name has changed. I think they did a release of a fulfillment platform a couple days ago. And I'm betting what happened is they changed the field name from snake case to camel case. So the model usually expects this to be snake case, and this is what tells the model how long it takes to actually do a drop off. Ashley, this would explain why the routes are going over the expected time, and we're ending up in overtime. There's just too many things assigned to a driver. Sebas, do you know who's on call this weekend, or is there an SRE that can look at this? If we can deploy the platform, we can just fix this.
Yeah, I think Haley from DevOps is on call. Let me just ping her real quick.
Hey folks, thanks for the ping, Sebas. It sounds like you could use some help. What's going on?
Hey, Ellie, good timing. Yeah, we're addressing a bug in the latest release of the fulfillment platform. This is the input that it sent to the most recent routing production model. As you can see, the stop duration field has changed from snake case to camel case, and that is that is not taking into account the time it takes to drop off deliveries, and so the routes are getting too compact. Is there any way we can make this change on the fulfillment platform side and just push that out? That will fix the model, I think.
Okay, yikes. This isn't great. All right, so okay, so it's probably going to take a few hours to go through all of the Lambda traffic shifting on the software side. And if I remember correctly, I think Ash, you're trying to get out of town here. I'd prefer to save a little bit of time. Ryan, is there any way we can make the change on the Nextmove side instead?
Yeah, I mean, that should be pretty simple. I haven't looked at this in a little while. Let me just look at the schema and see if I can find where this field is. Okay, this is it. Yeah, you know what? I can just remove the annotation on this structure, and I think I can just deploy this right into production if we go through the tests first. All right, Ashley, I have made this change locally. Let's test it out.
Okay.
Handy dandy. So I think it was only 4 vehicles were assigned in the last in the output on the last one, and only 4 vehicles were used and every stop was assigned. Let's run it locally and see what happens. Okay, this looks better. I've got 5 used vehicles. 6 unassigned stops. That's probably a bit more like what we see in production normally. Okay, you know what? I'll just push this right up to staging now, and then we can run a test and see what happens.
Ryan, as you're running this test, it looks like you have what you need here. And Sebas, I'm assuming you've got what you need. Does that sound about right?
Yep. Thanks a lot, Haley, for your help.
All right, awesome. Then I will let you do it. Ash, have a nice trip.
Yeah, bye.
Ryan, now that you're pushing this model to staging or pushed already, can I just share my screen to talk everyone through what I'm seeing here?
Yeah, sure. Take it away, Sebas.
Thanks. Right. So I was looking at the patch she just uploaded, and I just want to take a look at the value, which is the duration of the routes. And I can see that for the staging one that you just pushed, the mean is higher. And that makes sense because now that we are accounting for service times, I would expect a longer route. So that makes sense. And let me just take a look at the unassigned to confirm what you were seeing locally. So yeah, I can see higher unassigned stops, which we still have to do something about.
Yeah, I mean, we have been seeing an uptick in orders, but I guess that's what happens when business is growing. That's a good thing.
Right, yeah. So you know, Ashley's getting out of town. Here's a quick proposal. Let's just ship the new model with service times. I'll message finance and a few others to activate our contractor pool. And I think that should get us through for now. Ash, does that work?
Yeah, I think that'll work. I'll see who can work an extra shift for this weekend, and I'll get plans out to the team before I leave today.
Cool. And all right, so I see that Ryan, you already started some more experiments.
Yep.
So I think we can just chat about that next week, if that is okay with you.
Yeah, sounds good. Ashley, I have switched over the new model since the experiment looked good into production. Do you have everything you need to make your flight and deal with the drivers?
Yeah, I do. Thank you so much for your time, Ryan.
Great. Yeah, have a smooth flight and enjoy Miami. It should be really nice there right now. I'm jealous.
Thank you.
All right. Thanks, everyone.
Whew, okay. All right. Well, that wasn't how I was planning on showing this, but I think it actually gave us everything we wanted to talk about anyway. So let's just roll with the rest of the talk. So what just happened there? Well, first thing that happened was collaboration. This gets to the several people we're optimizing. As you can see, what we were able to do with this tooling was bring in lots of different stakeholders from different places in the organization who have different needs, different concerns, and different timelines, and get them to sort of work on a bug together. And that could be a production issue with a model, or it could be just something that needs to change, or something new entirely. So in this case, what we did was we identified an issue with an existing routing model. The issue was actually fairly simple. We investigated it, we updated it, we tested out a solution. We tested it against old data that we had saved from previous runs. And we were able to look at the output of that change and see if it would behave the way we thought it would. We wanted it to in production. That was our experimentation part. And then we published it when we were happy to production, and boom, we were using the fixed model. So what made this collaboration possible? It really comes down to three things. One, we need a speedy deployment workflow. We need to have a very short path between people doing model building and making changes to models and having those models in production. And so that was the next move push command that you saw from the command line. We also have to have a space for sharing our work and findings. So I can run an experiment as a decision scientist, and I can share that with my product person. I can share that with my logistics operator, and so on and so forth. And then we have to have a way to test our experimentation and iterate on these workflows. And together, these things make this kind of collaboration happen. So let's break that down a little bit and look at what those individual components, those three pillars, sum up to. So if you've done operations research for a little while, you probably have sort of a workflow in your mind that looks like this. This is the way we learn operations research or optimization when we first come to it. We talk to stakeholders, we elicit requirements. Oftentimes this might mean figuring out who the stakeholders even are. We translate those requirements into the solver tongue, I like to call it. As the optimization person on the team, we're probably the only person who speaks this language. We have to test those models somehow, sort of an open question as to how. How do you know a model is really doing the right thing? Frequently, we then work with a developer or a team of developers to wrap that model into a service and put it in the cloud. And so all the things that go to hooking it up and making it run and scale and appropriately are open questions that our development team has to answer, oftentimes with our help. And then we live test, which again, testing is a sort of an open question a lot of the time in optimization. What does live testing mean? How do we do it? How do we know it's behaving the way we want? And then we field questions often directly from unhappy operators. This route was Z-shaped or X-shaped, or there was another driver standing next to this restaurant where it assigned, the order to somebody who was, 100 yards away. Why did that happen? And what you see here is this sort of very analyst-centric workflow, as opposed to a team workflow. So some of the challenges that we experience in doing this, one is the microservice architecture. Building the model is actually just the beginning of our task. It has to know how to function in a production software environment. It has to be able to interact with databases and data stores and observability platforms and logging and so on and so forth. It needs to scale up appropriately as demand comes in. There's also infrastructure setup and maintenance. So how do we monitor those servers that are running these things? What happens when they are spiking on CPU or running out of memory? These are questions that if we're going to put these things into production, we have to answer. And doing this with optimization is frequently much more challenging than doing it with other software components due to the way that optimization works and some of the nature of the beast. We also have to version things. So this is, something that is often done in microservices and other service-oriented architectures, that we have to be able to flow from development into staging environments and into production environments. And there's not necessarily a canned solution to that with optimization technology. It's also important to be able to replicate things so you can study them. This is maybe even more important in decision automation than other fields. What was the model that was running last Thursday when it made this weird assignment? Can I replicate that and debug that on that model? And if I fix that, what will that mean to new instances of the problem that I see going forward? So if you've been working in optimization for a little while, you've probably been on this, had this experience. I certainly have. This is actually from the same article that we looked at the beginning. You walk into an environment where somebody built a model once. They brought in an optimization person to do that. It was an analyst-centric workflow. They worked with a software engineering team. Maybe it got recoded, maybe it just got wrapped, who knows? And then sort of nobody ever touches it after that. Maybe this was a consulting relationship, or maybe the person left the organization. But since there isn't a collaborative environment around that particular piece of software, there's essentially no ownership of it if that optimization person isn't looking at it all the time. And so it's very easy for this sort of thing to happen. And if you have a model that is stale like that, it's not changing and adapting with the business, and that's bad. So our belief is that deployment and all of these things should be very easy. They should be innate to the workflow and the tooling that you do these things with. So through our command line, we saw some of this in the speed run. We can install, configure, we can build locally, and we can push to production, and things sort of just work. They just flow with these commands. Another important thing to putting models in production is the support for multiple solving paradigms. There's a lot of different optimization tooling out there or solver technology out there, and most of it is not going away. We're not going to replace all of it with, a large language model anytime soon, I don't believe. We will still have, mixed integer programming, decision diagrams, heuristics, and constraint programming, and all this other stuff for a good long while, because these things adapt well to different problems. And so that's a lot of the motivation of like the hybrid optimization community, is that different technologies work better on certain kinds of problems, and sometimes you want to combine them or be able to switch between them. And so it's important for a platform that does deployment of optimization models to be able to handle different solver technology or different even high-level engines that solve vertical specific problems in the same way. And so we put a lot of effort into making sure that irrespective of whether a model is a MIP model or a heuristic model, the environment that executes those things and the way that you interact with them is consistent and the same. And then we get to things like endpoints and documentation, which those technologies and practices have also built up a lot over the last several years. They've models that are deployed into production environments essentially become endpoints, and there should be automated documentation and happy paths, well-known paths for interacting with them. So we try to provide those things too. And the end result of all of this, the combination of this, is that we essentially go from being these bunnies over here where we're trying to get across this chasm where there's fire and there's dragons and there's maybe a hydra or something, and we don't really have a bridge, right? So we have to build our own bridge, and we're trying to figure out how to do this. And we move from that world where we're saying, okay, I don't know how to get across this. I don't know how to bridge this chasm, to one where we essentially have a Stargate. I've built this thing locally. I'm happy with it. I can share my results with somebody, and I can just, teleport. And so that's what the user experience should be like. And in that experience, what do we have? We have this sort of microservice architecture that's just innate to the tooling, right? Once you built the model, boom, it's a microservice. It's very easy to publish. All of your services behave the same way. You don't really have to think about these sort of boring questions of how do I call it? What will it scale? That sort of thing. The things that you shouldn't have to be focusing on. You should be having to focus on your business and the operations that go into that. You also have infrastructure that just works. Models will scale as more demand happens, and so you don't really have to think about we forecasted more demand for Q4, therefore we're going to have to scale up our infrastructure to meet that. And similarly, version management and testing is just something that you can build on top of it very easily and work with very easily. You can always replicate the run that happened last Thursday when that weird decision was made by the model. You can always fix it and test it and move forward. And this is kind of what that looks like in terms of pipeline and versioning. Here we have a delivery app where maybe I have one version of this or one instance of this. This is for New York, and in Philadelphia, I've heard it's really hard to park. And so we actually have a different adaptation of our model to deal with that. Or it could be the production, staging, experimentation instances. And so whatever your workflow is, however you think about these things operationally, there's a way to match your pipeline to that for your model ops. You also have a space to share. So this was what enables a lot of the collaborative stuff that we just saw. In that analyst-centered workflow, what is essentially happening is that all the different stakeholders who have different needs, who have different questions in their minds, who have different ways of thinking about the world, are really going through the operations research analyst. The product owner wants to know what's going to happen with KPIs. Are we going to be able to deal with demand surges, so on and so forth? Logistics is maybe dealing with more on-the-ground questions, like why is this driver seeing these weird routes, or why did this assignment happen? And on the DevOps side, they want to know, how are we deploying these things, and is it executing fast enough? What's the CPU look like? Are we going to run out of memory? How do we roll out new changes, and what's the gatekeeping process for that look like? And with the analyst-centric workflow, you're essentially sort of sitting in here trying to bang your way out of these bricks up to the question mark. And when we move from something like that into a collaborative platform, what we're essentially doing is breaking down barriers. So here we can see we have this farm share team, and we have all of the people on that farm share team just together in a space. We're just working together on a team, right? It's almost like a squad. And so this moves us from a one-on-one communication paradigm where all the conversations are completely different to one that's a little bit more like a Slack channel. We have our logistics operator saying, I'm seeing this thing, our decision scientist saying, I can run back last week's data, and so on and so forth. And this moves us into the several people are optimizing workflow. And the third pillar is experimentation. If we don't have experimentation, obviously there's really nothing for us no way for us to say, this model change, here's how it's going to behave. So we've been thinking a lot and working a lot on sort of how to break down testing into different kinds of buckets. And we've developed sort of a taxonomy where we have things like shadow testing and scenario testing, debugging, which might be local activities a developer would do. And sort of each of these kinds of testing live in different places and have to sort of be supported in different ways by the platform. And so as we've done this, we kind of grouped them together into things like, online, offline, real-time, so on and so forth, and come up with this model testing framework. And so what you saw today, we did local testing. So that was me working on my machine. I'm developing, I'm debugging, I'm iterating. And then we saw batch testing, which was I was running this new model change against a curated set of inputs. And I was sharing that with my operator and product person to see what they thought. On top of that, we're building out real-time testing capabilities for things like shadow and switchback, so you can actually do these things online in real time in your production environment. So if you take away nothing else from this talk, what I'd like you to think about is that decision science and optimization is a team sport, and in order to manage that, what we need are essentially collaborative workflows and collaborative tools. These are made possible by a unified platform that brings all the different stakeholders across the organizations who need to worry about a model together. And that these experiences then are made possible by very seamless deployment, sharing, and experimentation capabilities. And that's all the time that we have for today. We're actually going to the thing that we showed you today was a delivery routing model. We're going to follow up with a screen share of an allocation model that's also on the farm share. But yeah, thank you for your time and attendance.
Excellent. Thank you, Ryan. And love to see the teamwork in action there. So like you said, now we're going to take a look at some of the questions that have come in. Don't forget that you can use the chat feature or the QA. So, all right, first up we have, is version control of model code and code review integrated into the cloud-based tooling or done separately based on Git, etc.? In the demo, the team only looked at changed results, not the changes themselves.
Yeah, we do have versioning and instance set as well, our instance creation in the workflow now as part of Nextmove Cloud and the command line tools. But the in terms of sort of the gatekeeping aspect of that is managed through Git at the moment. So we are interested in feedback on that because I think we would like a tighter integration between the platforms. And so, yeah, if you have thoughts on how that should work, we'd love to hear them. But yeah, most the stuff that we're doing right now is versioning and instance management on the model side on Nextmove Cloud, as well as input set curation.
Great. Okay. Next question I have for you, Ryan. Does the testing functionality allow direct comparisons, different solvers, or solving paradigms?
It does. Yeah.
Yeah.
Yeah, it does. And we've been using it that way a bit internally. Under the hood, we have this sort of ability to run just a very large set of tests with different models or different inputs. The caveat there is, of course, if you're testing the same problem with two different solvers or two different models, you would need to have the same, output structures. But yeah, those kinds of things are possible.
Excellent. All right. Got another one for you here. Is the data for testing curated separately, or is it archived live data used automatically?
So for what I showed today, that was curated data that we had essentially saved from past production runs. So you could think of this as back testing. For all of the like offline testing that you would do, that would normally be the case. You would create an input set and then run the experiment against that input set. For the features that we're developing currently, those are going to be tests where every time a production run happens, there's either like a shadow run that happens as well with a different model, or it'll be doing switchback testing or things like that. And so for those tests, the inputs will be coming through the production environment, so they'll be essentially real time.
Alrighty, I think we are running up against the 30-minute mark now. So that's all the time we have for questions today. But you can always follow up with us through our contact form on nextmv.io. We'll also be sending you some resources shortly, including a recording of this today and the materials. We encourage you to create a free account. And also, we'll be taking a deep dive into testing on our next Tech Talk that airs on the 24th. So make sure you get registered for that one as well. And thanks again for attending today. We'll see you soon. Bye.
Thanks, everyone.